A confirmation about the audio, please, guys, if the audio is clear and available. Thank you. This data is important for 2025. So this data, basically what you see as an impact of air pollution, it is a representative data that will be helpful for your mains examination. See here also in this particular data, so there are certain types of data pointers which will be very pinpointed in terms of what they are trying to indicate, and certain data pointers which will give you a broad base idea of what is the impact or the overall, let's say, causation of any particular condition. So this particular data pointer that you have on your screen right now, basically that will be utilizable in your mains examination, in your essay paper, whenever you are overall discussing about the impact of air pollution. Always end up representing this data, because here, observe this data. Here you are seeing that in the case, what this data tells you is the impact of air pollution in terms of the lives, right? In terms of human lives, and also the impact on them. So when we talk about air pollution, first of all, now that air pollution has got significant amount of risk associated with, and various different types of air pollution, they will end up causing some amount of respiratory issues. They can end up causing cancer, and basically heart disease, and also can end up causing significant amount of strokes in the process. So over 7 million deaths, around 7 million deaths. This is not talking about that, okay, 6,445,595 deaths. So always in these cases you take a rounded data. That is why this data will be helpful for you. So when we talk about the impact of air pollution, let's say that you have to indicate over any particular area, always utilize this data. And which data you have to depict in the answer paper? When you are talking about, let's say, that role of air pollution, or the impact of air pollution, or the need to curb air pollution, if you highlight that almost over 2 million people, around 2 million people in Southeast Asian region, they are impacted by the process of air pollution. So that will add heft to your answer. That will provide some amount of authenticity to your answer. It is not about whether it has happened in 1.9 million or 2.1 million. Anyways, these data pointers, they don't change within a span of 1 year or 2 years. These data pointers, they end up having a kind of a formation or a definite trend pattern over a span, or over a period of, let us assume, over a period of a decade, 20-year, 50-year period. That is when you come at this particular data pointer. So I hope that is understood. Okay, so use this data pointer when you have to authenticate your particular point of view about the impact and how significant impact is created. So, and here also you have to understand which data to utilize when. Many of us, while writing the answers, what we end up doing is that we highlight that, okay, across the globe there is 7 million loss of lives, but we don't highlight what is happening in India. So for that, do use this particular data pointer. This is going to be relevant for your mains examination. Whether you are appearing for the mains in 2024, whether you are appearing for the mains in 2025, 26, this data pointer doesn't change immediately. It is only taken after a broad-based study of the patterns and the trends which are actually happening. Because please understand, a death which has happened due to air pollution, now, it is not as if immediately when there is a lot of smoke, people will start dying immediately. You will find that, for example, take the case of India as well. Oftentimes, you would have heard about the various data pointers that if you are living in this particular area of the country, the average life expectancy is reduced by 4 years, 5 years, etc. How do we arrive at that number? After a long-term analysis of those deaths, there are various researches which are carried on that an individual might have died from, let's say, a breathing issue or an asthmatic issue or maybe cancer. But after long-term analysis, some research paper will find out that, okay, this cancer was caused by air pollution. This particular kind of contamination was caused by air pollution. So that is when eventually you get an understanding. Okay. doctors mostly don't specify that this is because of pollution. That is true. Immediately, you don't get an idea. If someone dies because of respiratory failure, do you blame it on pollution or do you blame it on the internal organ functioning? So that is why this is a kind of a long-term data that you have to utilize, and you need to know how to utilize this particular data overall across the globe. The number of or the amount of population who do suffer from the issues carried on due to air pollution, that is increasing ever so slightly, and in many of the cases it is increasing exponentially as well. One common factor is something that you will find is that majority of the deaths caused are in the developing and the poorer nations of the world. Why? Because in these areas, because of the requirement of development, there is a greater amount of industrial activity, and industrial activity not in the sophisticated form, in the unorganized sector, where the emission norms are not significantly followed. But the pollution which has been caused has been historically created by whom? Historically, that pollution has been created by the European nations and by the North American countries. They have developed based upon that aspect of pollution. And once now they have developed, they have purified their methodologies of industrial production, industrial activity, and then the rest of the world, who is simply following the footsteps, they are pinpointed and there is a blame pointed on them. We will understand that when we talk about the geopolitics of climate conventions, etc. How is it that these climate conventions are played out? How is it that the various different countries, they try to peddle on their own various different types of agendas? How developed nations have always shied away from taking responsibility of the pollution? So that is where you'll get a broader perspective about that. Okay, now after this, when we talk about the principal air pollutants, that is the majority of the pollutants which cause air pollution. So you have carbon compounds, carbon compounds such as carbon dioxide, carbon monoxide, okay, carbon dioxide, carbon monoxide, right? Now, they are created by combustion of fossil fuels, by burning of biomass, any kind of incomplete combustion or even complete combustion in certain cases, they will produce certain amount of carbon compounds in the process. Burning of biomass, industrial emissions, all of these will end up emitting a lot of carbon compounds. You also have another carbon compound which is emitted, which is a significant pollutant, and that is methane. Methane is what? CH4. Now, one of the prime causes or the chief emissions of methane is created how? By the agricultural process, be it by animal husbandry or be it the crop residues, the decomposition of biomass, all of them, they also end up producing a lot of that methane. Then you have sulfur compounds. Sulfur compounds, that is SO2. Now, they can be produced by thermal power plants where you end up burning fossil fuels as well. They can be produced by the industrial processes, and they can also be produced by vehicular emissions. Vehicular emissions. Then after that, you have nitrogen oxides, N2O and NO2. So here they are produced by automobiles, power plants, industries, agricultural activities, all of them. They produce nitrogen oxides. Then you have ground level ozone, or the ozone which is produced in the region of troposphere. Ideally, we do know that in the region of stratosphere, we have a thick layer of ozone, what we refer to as ozonosphere. Now, here at the ground level also, you have the production of ozone, which is referred to as a tropospheric ozone or ground level ozone. And this is primarily a secondary pollutant. This is a secondary pollutant in most of the cases. Okay. Then fluorocarbons, that is chlorofluorocarbons, hydrochlorofluorocarbons, bromofluorocarbons. All these fluorocarbons, they are damaging when it comes to the ozone layer present in the stratosphere. They end up punching a large hole in the ozone layer itself. So they are created or emitted by the industries, insecticide sprays, even when we talk about fire extinguishers, for example, all of them. And then comes the particulate matter. Particulate matter, we have already seen, is classified depending upon their size. So you have PM 2.5, PM5, PM10. All of these are the various varieties of particulate matter. Now, smaller amount of particulate matter, they can be produced even by burning of biomass. And the larger size of particulate matter, they are generally given out by the industrial emissions, where ash is not treated well, and also by the construction activities. In many of the cases, construction activities and the dust particles which are emitted. Now, if I ask you that which of them is more dangerous, PM 2.5 or PM 10, which of them is more dangerous for humans? What is the solution here? Good, correct. So most of you are correct here. It is basically PM 2.5 which is much more dangerous. Why? Because these are so very small in size that they are not even stopped by the respiratory process. Because when we take in air, when we breathe in air and when we breathe out air, now in that, the mucous membrane and the mucous layer that we have in our respiratory tract, right from the nasal membrane, now they end up trapping a lot of that dust particles there itself. But PM 2.5, it enters the respiratory tract, and then it can puncture the lung. It can end up getting accumulated in the lung, causing lung infection, perforation of the lung membrane as well. So, more dangerous because of smaller size and it enters into the respiratory tract. Okay, so that is where we have these as the principal air pollutants. And here you have a list which talks about the pollutants, the major pollutants, and then the sources of pollutants, and also the health problems associated with them. Now, for all the various different air pollutants, other than, let's say, lead, majority of the air pollutants, they will be damaging the respiratory tract, they will be damaging the heart, they will be the cardiovascular diseases as we refer to them, or they can end up causing a kind of a brain stroke. So that is the impact of it. Okay, so that is where you have the various different pollutants, the sources, and the health issues. All the health issues with the air pollution are associated with the respiratory tract or with the kind of brain hemorrhage or stroke. Okay, now after this, we come to the portion which UPSC is really concentrating upon for the past few years, and that is the ground level ozone. So, in the past few years, UPSC has already asked this particular portion in the prelims as well as in the mains examination as well. So, what is this ground level ozone and the smog which is produced in the process? So, when we talk about smog, smog is basically a kind of a hazy creation where you have a combination of smoke which combines with the presence of a foggy condition where you have a fog and then smoke commingles with that, and that is a smog. Now, smog is something which you will observe in majority of the Indian cities due to the creation of pollution, but is largely concentrated in the northern part of the country because of conditions of foggy conditions right from the month of October, November, December, January, February, and on. So that is where the smoggy conditions are created. Now, when we talk about ozone, ozone in itself is classified into two types. One is what is referred to as the good ozone, and another one is what we refer to as the bad ozone. Where is the good ozone situated, or what is good ozone? When we talk about good and bad ozone, what is good ozone and what is bad ozone? Do we have any idea? Good. Very nice. So basically, the good ozone that you see is the ozone present in stratosphere. Okay. So that is ozone. Good. Gulam, Avni, Himanshu, Sridevi. Perfect. So this is ozone produced and present in stratosphere. Why? Because it will lead to the filtering out of the ultraviolet rays. And bad ozone is the ozone which is produced in the region of troposphere or at the region of the ground level. This is a pollutant. So produced at the ground level, right? And is a secondary pollutant. That is the basic classification. Now, here, when we talk about air pollution, we are largely concerned with the productivity and the production of bad ozone. So, how is it that this bad ozone is produced? What is the process here? So, this schematic image ends up indicating the production of bad ozone. So, here you will see that it is not directly emitted into the air, but it is a resultant of the various different chemical reactions. Chemical reactions between what? Chemical reactions between nitrogen oxides or the nitrogen compounds along with the volatile organic compounds. So here VOCs, they always will refer to the presence of volatile organic compounds. That represents what we refer to as, or what we regard as, the VOCs. Okay. So that is where in the presence of sunlight and heat, that is a must. Okay, this reaction cannot happen in the cloudy conditions. This reaction cannot happen if there is no sunlight. So only in the presence of sunlight will this reaction happen, and you will observe the presence of ozone or the production of ozone. So that is a must. That is why this tropospheric ozone or bad ozone is produced in large chunks and significant quantity during the summer months, when you have adequate amount of sunlight and heat as well. But even when it is produced during the winter months, it will be produced during the daytime. Okay, so here emissions from industrial facilities, electric utilities, motor vehicles exhaust, gasoline vapors, for example, when you, let's say, have a lot of fuel, petroleum, for example. Now, petroleum overall, when you keep it outside exposed into the environment, it tends to evaporate, right? So that also ends up producing significant amount of volatile organic compounds. So all of them, they are major sources of oxides of nitrogen and the various different volatile organic compounds in the process. So here is the written portion that you need to have in order to provide a detailed answer depending upon the pattern and based upon the pattern that UPSC is framing nowadays. So here you'll find that the ground level ozone, it is a colorless and a kind of a gas that you don't end up feeling or immediately perceiving that yes, this is ozone, and it forms just above the earth surface. It is a secondary pollutant, and it will be produced in the presence of sunlight in stagnant air. Okay. Now, the primary pollutants are nitrogen oxides and volatile organic compounds. Both of them can be produced both from natural sources as well as from anthropogenic sources, that is, human factors. So, around 95% of nitrogen compounds, they are emitted by human activity. For example, burning of coal, gasoline as in fuel mixture, oil in motor vehicles, homes, industries, power plants, that is a source of nitrogen oxide production. It is here that you have or you observe production of nitrogen oxides. Okay. Then volatile organic compounds. Volatile means what? What is the meaning of volatile? It means it can change its form and state very easily. It can end up reacting very quickly. It is not stable. Volatile is what? Something which is not very stable, which can very quickly change its state, form, as well as the characteristic or the nature of it. So VOCs from human activity, they come mainly from gasoline consumption, from upstream oil and gas production, residential wood combustion, and evaporation of liquid fuel and solvents. Even for that matter, when you use, let's say, the polishing of furniture. Now, even the smell that you have, all of us must be aware of that. The smell that is emitted. Now, that is also in a way a kind of a volatile organic compound. It can change its state very quickly and very soon. Now, significant quantities of volatile organic compounds, they also originate from sources such as coniferous forest. How? How is it that these can be emanated or secreted from the coniferous forests? And here, when we talk about coniferous, that means the boreal forest that you have, where you have the needle shaped leaves, you have the conical shaped trees. So, from there, how is it that VOCs are emitted? So, basically, if you recall what we have studied or what you have studied in the portion of geography earlier, that these coniferous forests, majority of them, for example, take the case of cheer pine. Now, what they end up doing is the leaves, or also in terms of their stems or twigs, they end up secreting a natural oil. It is that natural oil which can also be utilized for manufacturing of biofuel, as is being done in the region of Sikkim. But also that natural oil which is secreted, that also gives rise to a lot of forest fire, right? It serves as a kind of a fuel for forest fire. So that natural oil, which is secreted from the leaves, from the various different portions of the branches, stems, etc., that ends up effervescing, and that ends up evaporating in many of the cases, and that produces a significant amount of these VOCs. Is it the sticky or gummy like substance? Yes, something of that sort that you will always associate with. So, this is secreted by the plants, can be used for making biofuel. Okay, that can be used for manufacturing of biofuel. But please understand, Sridevi, please understand here that not all the sticky or the gum-like substance or the jelly-like substance that you see in the normal trees, they don't fall into this category, because many of them, they also end up secreting what is referred to as lac. So, but that is also flammable. that also ends up producing volatile organic compounds in the process, but not all of them. Largely concentrated in deodars, cheerpine, poplars, etc. Okay. Now, then we come to the portion of photochemical smog. So, understand what is the difference between a smog and a photochemical smog. That is important. Okay. So, when we say a smog, it is very simple in the sense that it represents smoke plus fog. That is what is referred to as smog. So, under normal circumstances, this produces a haze like substance, haze where the visibility is reduced significantly. And when you have fog, fog is something closer to the ground or far away from the ground. Always, fog is something which is much closer to the ground. So, you end up inhaling that. And that is why it causes a lot of various different issues. For example, take the case of the very disastrous London smog. London smog, which happened in the early 1950s. That is where, due to a condition of temperature inversion, you had the persistence of that smoggy conditions for a very, very long period of time. And further combustion of fossil fuels and particularly coal based fuels that contributed to that smoggy condition. People would be forced to inhale that, because you cannot say that I won't inhale this particular air. Air purifiers are a thing which is a norm now, but not earlier. So people would inhale that. A lot of them immediately they started suffering from nausea, diseases, and many of them even lost their lives in the process. Because when we have this smoke, in this smoke, always you will find that carbon monoxide, CO, is a major constituent of that smog or any smoke. Whenever you encounter any kind of smoke, you will always end up inhaling a lot of carbon monoxide. Now, the problem with carbon monoxide is it enters your bloodstream, right? Obviously, how? You take in, and it is taken in the lungs from the alveoli. Then there is a blood or the air interchange in the blood, and that is when once it enters into the blood, the oxygen carrying capacity of the blood reduces. The blood starts turning pink, right? It turns very bright red to pink. Normally blood is dark red, so but when it is infused with significant carbon monoxide, it turns pinkish. And that is when the supply of blood to the body reduces and people die. So earlier what used to happen, which was a norm in many of the areas, in many of the domestic households, it was a norm. During the winter months, they would fire up a coal stove or a coal based stove in the house. They would close the doors and the windows to provide them with some kind of warmth. But this was carried out in rural areas. This has been carried out in the rural areas for quite some time. Now, in rural areas where you have mud houses, you always will have some or the other way in which that carbon monoxide can escape or natural ventilation can be carried out. The problem started when this was implemented readily without thinking in the urban landscape. Now, in the urban landscape, obviously, the amount of ventilation is never going to be the same. And that is when, in the late 90s, lots of such deaths started being reported in the winter, where the pattern of the deaths were very similar. The pattern would be that a family would sleep and would during the winter nights they would sleep into their rooms, and they would keep that slow burning coal oven or a coal stove into their room, and they would close the doors and the windows to provide them with warmth. And then the pattern would be they would never wake up. Even if one or the other adult would survive, but the kids and the older ones, they would never survive. And all of them would die because of carbon monoxide poisoning. So that is when it was understood that this carbon monoxide, how dangerous and damaging it can be. Now you don't find that kind of a pattern in general. So that is what your smog is. Now, this haze, when it is produced not because of fog, but because of chemical reactions taking place, that is what is photochemical smog. Photochemical, it is made up of two words. Photochemical. Photo means there is a utility and there is a role played by light. So photo here indicates the importance or the role played by light. Okay. And chemical, because of the chemical reaction. Chemical reaction. Between what? So chemical reaction between nitrogen oxides, volatile organic compounds, and also large amount of unburnt hydrocarbons, the residual hydrocarbons, which have not been burnt completely. They will also end up forming a reactive surface. And that is when that chemical reaction ends up producing this photochemical smog. So it is a mixture of pollutants that are formed when nitrogen oxides and volatile organic compounds react to sunlight, creating a brown haze above cities. Now, here you might get confused that this is the same reaction that we saw in the case of ozone, ground level ozone. Now, here we are talking about the production of photochemical smog. So, is it so that ground level ozone and photochemical smog is the same? The answer is no. The answer is that for the production of photochemical smog, ground level ozone is an important intermediary product. That ground level ozone production, when it happens, then further chain reactions are kicked in, and then after that you have the production of that smog. So that smog is what is also referred to as this photochemical or the chemical compound which creates that hazy substance, that is also referred to as pan. Right? What is pan? That is peroxy acetyl nitrate. That is what is produced in the process. Peroxyacetyl nitrate. So it tends to occur more often in summer because that is when we have the most sunlight. So take a look at the reaction. This is your pan, which creates that haze. Now, how is it formed? First of all, nitrogen oxides will react with sunlight, and in the presence of sunlight, there will be one oxygen radical which will jump the ship, and you have NO. Now, that NO or this individual oxygen that will combine with the atmospheric molecular oxygen that you have and will end up producing ground level ozone. This is your ground level ozone. Okay. So observe that this is an intermediary stage. This is not what is referred to as a photochemical smoke. This is just an intermediary stage in the series of reactions which will happen. Then after that, ozone will react with O3, or ozone will react with NO. There will be another production of NO2. So this process continues. Now here, NO2 produced in the process or in the intermediary stages as well, they will end up interacting with the residual hydrocarbons, the unburnt partial hydrocarbons, the volatile organic compounds, etc. And that production will lead to the formation of pan, and that pan is something which is harmful for the entire region. Now, that produces a brownish haze over cities, generally observed during daytime, even in regions such as, for example, take the case of Bangalore. Now, even in certain months in Bangalore, when it is not raining, when it is not particularly, let's say, windy, even if you wake up early morning in the region of Bangalore, let's suppose in the month of April, May, you will observe this smog. In the region of Delhi, while and in other parts of North India, while this is something which is experienced for almost throughout the year, it becomes very persistent in terms of the summer condition when you have the brownish haze. If ever you have, let's say, whenever you get an opportunity to fly into Delhi, now, before you land, you will observe that the sky above is very, very blue. It is very clear. And suddenly, when your plane starts descending, it is as if that is overpowered by a kind of a blanket of haze. That is oftentimes that pan peroxyacetyl nitrate, or what forms the reduced visibility and the brown haze that we refer to as photochemical smog, produces significant brownish haze. Okay. Now, the main source of the hydrocarbons that you see is the volatile organic compounds. Similarly, oxygenated organic and inorganic compounds, they will also react with the NO, and that will produce nitric oxide and more nitrogen oxides. The more nitrogen oxides they keep on getting produced, the reaction is further exaggerated. Okay, the more amount of nitric oxide and nitrogen compounds that you will find, the reaction gets a booster, so to say. Okay, now after this we come to the portion which is referred to as the acid rain. What do we understand by acid rain? In simple terms, raining of acid, that can be termed as acid rain. But how is it created? Now, this acid rain, by the way, is also a resultant of the secondary pollutants. So, due to the normal processes, when we end up releasing significant amount of, let's say, nitrogen oxides, or let's say sulfur oxides into the atmosphere, it stays in the atmosphere for some time. And after some time, it ends up reacting with the water molecules. And upon reaction with the water molecules, it produces a dilute or a slightly acidic, right? So you have production of sulfur, production of weak sulfuric acid, and weak nitric acid. How? When you have the sulfur dioxide and the nitrous oxides, they end up reacting with the water, the moisture, the droplets of water that are present naturally in the atmosphere. Now, acid. Acid means it is acidic in nature. Acidity is determined by what we refer to as the pH value. So when the pH value has its range lesser than 7, that is when the substance is referred to as acidic. When the pH value is 7, it is referred to as neutral. When the pH value is more than 7, it is considered to be alkaline or basic in nature. So when these gases react with water molecules and oxygen in the atmosphere, mildly acidic sulfuric and nitric acid, they are created and they form what we refer to as acid rain. Now, acid rain can be of two different types overall. Acid rain can be in the form of wet deposition. It can also be in the form of dry deposits. So what is the difference between them? So in both these cases, the sulfuric acid or the nitric acid that is produced, that is something which is suspended into the atmosphere, because these are very tiny droplets which are produced. Now they oftentimes remain or stay suspended into the atmosphere. Okay, and these tiny droplets, also what we refer to as aerosols, now naturally over a period of time they might start depositing themselves over any surface. But then sometimes what do you have is, let's suppose you have the occurrence of rainfall in this area. Let's suppose you have the occurrence of rainfall. Now this rainfall which will happen, the rainwater or the rain droplets, that will interact with them, right? And these rainwater, that is The acidic, this is your acidic rainwater. It can be sulfuric or nitric acid. So that acidic rainwater is received on the ground surface. That can happen. Sometimes what can also happen is, excuse me, sometimes what can also happen is, let's suppose you have these particles which are suspended into the atmosphere. These tiny aerosols, these tiny substrates or pollutants which are suspended in the atmosphere. Now, they might get carried over by the wind movement. So they might get carried over by the wind movement. And because these are suspended particles, suspended light acidic particles. Now, when you have these suspended light particles, with the help of the wind, they might get blown over and they might end up depositing themselves on the ground surface, depositing themselves, let's say, on any particular monument, on the crop fields, on the soil, and eventually have an impact. So, wet deposition is caused due to occurrence of rainfall or precipitation. Occurrence of precipitation. And then dry deposit is created due to movement of winds. These deposit the acidic particles on the surface. Okay. Now, here you have the schematic representation of acid rain. So here, if you take notice, basically, you will observe that nitric oxide and sulfur dioxide, all of them, they are produced by the various different sources of primary pollution that we have seen. They get transformed to H2SO4 and nitric acid. So sulfuric acid and nitric acid. Now, they are carried by the wind. Oftentimes that wind can lead to the formation, and along with the rainfall and precipitation, it can end up forming a kind of a deposit in certain areas, acidic rain, and then wind-borne gases might end up leading to the deposition on various different surfaces. Now this has got numerous different types of impact, either wet deposit or dry deposit. Both of them have numerous impact. For example, the ideal example is the case of the Taj Mahal, the yellowing of Taj Mahal. Now, there was this curious case where Taj Mahal started turning yellow almost around a couple of decades back. Obviously, it was not by design. It was not a kind of a larger design by Shah Jahan that after 400 years when I have died, after that the my monument will start turning yellow, then green, etc. No. So, upon greater investigation, it was found out that these are acidic deposits that are forming on the whitish marble of the Taj Mahal. And upon further investigation, it was found out that these whitish deposits that you encounter, that you observe, or these yellowish deposits rather that you encounter, all these yellowish deposits are a result of the acidic creation due to the lot of brick kilns which started operating on the other side of River Yamuna. Across the banks of River Yamuna, obviously on one side you have Taj Mahal, and then on the other side you had large number of these temporary brick kilns which started operating. So that is something where this, or that is a place where Supreme Court came down very heavily on the state government of that point of time, and also various different bureaucrats, because not any of these industries, none of the industries can operate in such sensitive areas without the connivance of the people in power. It is obviously the people in power who allow these things to happen. Only then these things will happen. Otherwise, they have the capacity to bring it to a complete stop. So that is where the yellowing of Taj Mahal was stopped eventually when all of these were significantly shut down. All the industries were brought to a shutdown. Similarly, in the region of Eastern Europe as well. Now, Eastern Europe also has experienced various bouts of pollution, large scale pollution. Now, in Eastern Europe as well, it was observed that various different monuments, they have indicated a kind of sort of large scale corrosion of substance. The substances, they started getting corroded, and the various different monuments, statues, etc., portions of it started falling down on their own. It was later on understood that the structural integrity of these monuments have also been weakened substantially, purely because of the impact of that acid rain. So that is where you have the effect of the acid rain. So when we talk about the effect of the acid rain, first of all, the soil. Now, in this case, whenever you have acid rain, the soil turns acidic. And we have seen in the first session itself that the pH value of the soil in a way ends up determining the types of plants or the crops that it can support. When the soil starts turning acidic, not only do the type of plants that it can support varies, but also the various different soil organisms, the from microscopic to macroscopic, from small worms to the microscopic organisms, all of their life cycles, they are also impacted. Many of the animal behavior, their reproductive pattern, all of that undergoes a change. So here, when soil turns acidic, what do we have? Can support a limited kind of flora, that is the plant species and fauna. And overall, soil fertility is hampered. And it is hampered quite significantly for that matter. And so is the case with the forest as well. The variety of species that you find in any particular forest, that is also restricted due to the acidic depositions that we have. Biodiversity in many of the various species of animals, and even in the case of the plants, the productivity of organic matter and biomass by the plants, that is restricted. And in the case of the animals, in many of them, their reproductive cycles, they are altered. Their The rate at which they reproduce, or if they reproduce or not, all of that is altered here. So when we talk about biodiversity, so productivity, then reproductive cycles, these are basically impacted. Okay. Then you also have an impact on public health. Obviously, acid rain is not going to be beneficial for us. When we talk about acid rain, it is not as if when you have this acid rain, your skin will start glowing, etc. It will have various impact, including the occurrence of skin cancer. So that is one of the significant impact can cause skin cancer. In the case of monuments, can lead to yellowing and corrosion of different various monuments. and structures. Okay, so that can also happen. And example, in India, there have been various areas where this acid rain has been a very common phenomena. So for example, you can take the case of Kerala. In many parts of Kerala, the occurrence of acid rain was a commonality. And then when we talk about the northern part of the country, there the dry deposits are very common. Why dry deposits are common there? Because in general, the amount of rainfall received is comparatively lesser. Then we come to the portion of pollution in northern India. Because when you read the news headlines or when you encounter the newspaper headlines, in majority of the cases that you would find, you would find or you would have an observation that majority of the polluted areas in India, they are concentrated in the northern part of the country, and large scale portions of the northern India, they suffer from significant pollution. And you will come across various different types of data pointers that 14 out of the 15 most polluted cities in the world, they lie in the northern part of the country. One other city, if you have to consider, you can consider one city in Pakistan, but otherwise almost all the polluted cities of the world in terms of air pollution, they lie in northern part of the country. So why is it so? Is it because people there like to pollute more, or is it because of certain or a combination of various factors? Let us understand that. First is, first basic fact is, when we talk about population density in the northern part of the country is much, much higher as compared to the central part, as compared to the southern part. All those who have covered the portion of geography, can we have a reason for this? Why is it that the population density in the northern part is so very high as compared to the southern part? Any of us? So population density is very high. Why is the population density very high? That was the question. Water availability, alluvial soil of Ganges led to more settlement. Very good. Fertile land, availability of water, and economic activities. Perfect. So here, the population density in the northern part of the country is higher because in general you have all the perfect conditions for population distribution that you encounter. Here you have very fertile land, alluvial soil which is brought by the various different Himalayan rivers. So you have large swaths of these soil deposits. Now, the availability of fertile soil provides for a unique economic opportunity where the people can grow various different crops, various different products on their own. Okay, so here that is another reason. And then you have availability of land in order to build your houses, to live, and construction activities as well. When we talk about, let's say, the southern part of the country, in the southern part of the country, because the topography is not very suitable, because you have the prevalence and the persistence of plateau region, hard rocky surfaces. So that is why population density in southern part is lesser. So southern part of the country is mostly, because the density is lesser, southern part of the country will be mostly dominated by green vegetation and green cover, right? You have the lack of enough agricultural area to cultivate. You don't have adequate conditions on the land to carry out construction activities. So all of them contribute to it. So because of that population density, high population density, the number of vehicles that you find in various different parts, that is also going to be very high. So the concentration of vehicles and absolute number as well, absolute number of vehicles and their concentration. This is very high. So, whenever you have a very high amount of concentration of vehicles and there is a larger population density, obviously there will be a lot of traffic issues, lot of traffic jams, and whenever you have traffic jams, there is significant amount of emission, isn't it? So that is one of the factor. Then other factor is industries. Population density is high. You have a lot of unorganized sector of industries. Organized sector of industries also persist, but along with that, you have a lot of unorganized sector in terms of the industrial land and the industrial availability as well, the industrial density as well. So these will also carry out. Many of them, they are very, very old, where you still don't have the modern scrubbers or the modern equipments to tackle the waste air and to treat the waste air. Then you have the power plants and refineries. Now these also become a source of significant amount of pollution. So when we talk about power plants, in India, majority of the power plants are coal based or thermal power plants. Okay, so majority is coal based thermal. For example, if you take the case of, let's say, the region of Badarpur. Badarpur is basically situated on the Faridabad border. Now, Badarpur power plant was established in the early 60s itself. And that was established to provide electricity to the industrial town of Faridabad, what was supposed to be a large industrial town. Now, that region of or that Badarpur power plant continued to operate as late as till 5 years ago. And it was shut down only after stringent orders from the Supreme Court, Honorable Supreme Court itself. Otherwise, it would continue to operate. Why? Now, in this case, obviously, we are a power hungry country as of now because we have our own developmental requirements. Not all the various different places and households still have the availability of reliable quality power supply. So, obviously, the supply or the requirement of electrical power is always going to be there. But to add on to that, you have to understand that these power plants, all these various different power plants, now they did operate on very old equipments. The modern power plants which are being established, even though if they are thermal power plants, they don't have the same pollution problem. Because when we talk about the modern power plants, they end up establishing what we refer to as the modern scrubbers in the case of industries and electrostatic precipitators. So, what are referred to as ESPs or electrostatic precipitators. Now, these electrostatic precipitators, they separate the waste from the gases and ensure that larger particulate matter and larger and heavier toxicants, they are not released as a methodology of emission. So, what is the simple construction of an ESP? Is something that you should be aware of. So, basically, when you talk about an ESP, it is a very large setup, as big as a 3-story building or a 2-story building, and as long as 2 to 3 car parks taken together. So that is how large it is. So if you take a look at these ESPs, it will have the presence of various different electrodes. Electrodes and membranes would be installed, and they are basically suspended here. Okay, these electrodes and membranes, they are suspended. Now, what happens is that all these, initially, they are at zero charge. All of them. They are at zero charge. They don't hold any kind of charge. These are large metallic membranes that we are talking about. Very large metallic membranes to the size of 2-story, 3-story buildings. And from one portion, you have the waste gas And from the other portion, you have the treated gas, which is then given out to the chimney. Which is then given out to the chimney. So here, what is done is alternate charge is in basically provided. That means charge will be provided, let's say, in this, this, and this. So alternately charge is provided, and one is kept at zero charge. So in that case, what happens? The air which consists of, or the waste gas which consists of various different particulate matter, other components, and other compounds as well. All of those gases, they interact with these charges. They get an interface with these charges. Now, these particles, they will also develop a charge. The various particles which are introduced into the setup, they will also end up developing a kind of a charge. All of them. Now, once they develop a charge, they will be sticking to these electrodes in a way, depending upon what charge they accumulate. Now, after some time, that charge will be withdrawn. And once the charge is withdrawn, all those stuck particles to the membranes, they will simply drop down. They will accumulate. So this is where you have accumulated waste substances. Okay. So here, the filtration is done by providing that alternate charged process. So wastes are segregated, waste is removed by provision of charge on a temporary basis okay, on a temporary basis, which in a way the particles stick to the membranes. So these electrostatic precipitators, by the way, can be referred to as a methodology or a kind of a solution to get rid of the various different types of particles and various different types of wastes which get accumulated or which are to be found in the presence of the waste gases. And that is where in the modern power plants, in the newly formed or the newly constructed power plants, if you ever witness them, you'll observe that much cleaner gas is emitted from the chimneys. Whereas in the older ones, you will observe that gases which are almost darker, blackish, that is something which is much more apparent. Then construction activities combined with the dry condition and the hot and dry conditions which prevail, those construction activities end up producing lot of dust particles. Okay, so it is not only construction activities, but along with that, the prevalence of hot and dry conditions that will produce the larger dust particles or particulate matter in general. So this generates lot of dust particles, particulate matter. Okay, that ends up generating significant quantity of dust particles or particulate matter in general. Then we have the problem of stubble burning. Now that stubble burning in itself is something which is significantly to be found in the northwestern part of the country. And it is not only restricted to the northwestern part of the country, it is also something that you will find in the adjoining region of Pakistan as well. Now, why does that stubble burning happen? What can be the solution of it? We'll take a look at it. But before that, we'll take a 10 minutes break. And after that 10 minutes break, we'll continue with that. Okay. So let's take a break for 10 minutes and then we'll be back. We'll talk about the stubble burning and also the geographical factors involved in the process. Okay. So now we talk about the portion of stubble burning. So when we say stubble burning, what do we understand by stubble? What is referred to when you refer to, or when there is a reference of stubble? What do we mean by that? So these are basically crop residues. Whenever you carry out harvesting, particularly of paddy crop or rice as a crop, so that is when the leftover portion of that paddy crop, that is what is referred to as stubble, which is also in the colloquial or in the local language, it is also referred to as parali. So that stubble or parali is basically, in this reference, it talks about the crop residue left behind after harvesting of paddy crop. Now, why is it that this stubble is eventually burned? Why is it that the farmers are forced to burn this? Now, for this, you have to understand the intricacies of the cropping season, more particularly prevalent in the northern part of the country. In the southern part of the country, you don't encounter this problem. But you encounter this problem in the northern part of the country, that is in the sections or in the regions of Punjab, Haryana, Western UP in particular, and also on the side across the border, that is in the region of Pakistan as well. So that is to do with the cropping season, right? Cropping season. So in this case, you have to understand that paddy is what kind of a crop? Is it a rabi or a kharif crop? All those of us who have already completed the portion of geography. So paddy is a kharif or a rabi crop? Good. Kharif crop. Very good. So when we talk about kharif crop, now the harvesting time, when is it harvested? Harvesting is done in the month of when? October. Late part of September and October. And then you also have to plant the rabi crop. Rabi crop in the northern part of the country, which is actually sown in significant majority, is wheat, right? So kharif is when you have the paddy, which is cultivated. Okay. Now in this case, when you have the rabi season, that is wheat in majority of the cases, so that sowing of the crop, it is primarily done in the early part of November in majority of the cases. So in this case, when we talk about, let's say, that particular clearing or the readying of the farmland before you plant the rabi crops, so after you have harvested, you are left, after you have harvested the crop, you are left with this protruding, the stubble and the straws, paddy straws, so to say, which are present in very large quantities. Now, these are very hard. These are very sticky, or not sticky in general, but pointy and hard. And there it is not easy to cultivate the land, in the land which is enriched or which has got substantial amount of paddy. So, or the paddy residues, it is not easy to till the land. So, because all these remnant portions, they continue to stick out. So there are only certain alternatives that the farmers normally can carry out. Either manually, they can pick it up, manually, they can remove it up, right? Or with the help of very sophisticated machineries, they can basically put an end to it. But obviously, that even if you carry out that manual labor, It is not something which is available cheaply. It will involve significant amount of price factor or the cost factor of the manual labor as well. So for a small farmer, it is not at all suitable or advisable as well in order to spend that large amount of money into taking out or extraction of that stubble. So what they end up doing is they will put fire to that stubble. They will burn it up in large quantities. Now various different state governments, they have formulated various laws in order to bring an end to that stubble farming, in order to bring an end to that crop residue burning. But then despite of that fact, the farmers continue to carry on the process because they don't see an alternative. So here, due to the short window, very short window or time available to clear the land, stubble is burned. Stubble burning also carried out after sugarcane harvesting? Yes, that is true. Even in the case of sugarcane harvesting, it is carried out. But then there, the problem is not very large scale, because majority of the sugarcane harvesting is done generally in the region of the western part of Uttar Pradesh. And now, anyways, the sugarcane cultivation is shifting to the southern part of the country. So here, that stubble which is burnt is majorly constituted of the paddy residues, and that is what is referred to as parali. Now, once that is done, then all that smoke, all that fumes which are emitted, and that would include nitrogen oxides, that would include sulfur oxide, sulfur dioxide, that would include particulate matter, they get suspended into the atmosphere for a longer period of time, and that is what creates the hazy and the smoky conditions across the northern part of the country, which is further exaggerated, let's say, by the industrial emissions, further exaggerated by the vehicular emissions, and also the colder conditions which start to fall upon in the northern part of the country. This is also exaggerated by the wind pattern. Now, during these months, that is October to November, in the northern part of the country, in the region of Punjab, Haryana, and Western UP, what is the wind pattern that we come across, that you observe? In what direction do you observe the wind movement to happen? Wind pattern, I'm asking about. Fog and smog, they don't end up indicating any kind of wind pattern. I'm talking about wind pattern. Which, okay, I'll give you a hint. Which kind of permanent wind system is in place during the months of October, November, in the region of northwestern part of the country? Are we aware of that? Okay. So during these months, as the ITCZ has already shifted downwards, you have the prevalence of the westerlies. The westerlies, which bring along with them significant amount of western disturbances as well. So these westerlies, they move from a direction of west to east. So the stubble burning which is carried out in the region of Punjab, Haryana, or even in the region of Pakistan, that all that smoke along with the westerlies, they end up spreading across the entirety of the northern India. So here during these months, we come across prevalence of westerlies. Westerlies. Okay? And this we are talking about in the northern part of the country. Okay. Now, all this existent wind pattern, what they will do is they will spread it over as their winds are moving from west to east. So this is westerlies, basically means movement of winds from west to east. West to east movement. Okay. So they will bring those pollutants, and that pollutant spreads over in the remaining portion. So you have the influence, or this is typically to be carried out in larger proportions. Carried out in which areas? In the green revolution areas. Why do I say green revolution areas? Because these are the regions where green revolution has been implemented in large proportion, and also these are the regions where you have large scale growing of food grains. That is the rice wheat cycle in which our farming or the agricultural sector is somewhat stuck into. So that is where you have the continuous rice wheat cycle, which is very prevalent. So it is carried out in Punjab, Haryana, Western UP, and even across the border in Pakistan. So that is the issue of stubble burning. Now, why is it not to be observed in the southern part of the country? Is it because the southern part of the country, the farmers are much more environmentally friendly as compared to the northern part of the country? Is that the reason? Why to burn? So they can use for other purposes like cattle feed. So the normal stubble that you have, it needs to be extracted from the ground, and then after that you need to treat it to soften it in order to have as a cattle feed. Okay, so it is the problem of extraction, my dear friend, due to which people are not doing that, because that extraction process where you have stubble sticking, so stubble is basically fixated to the ground. If ever you try to walk barefoot on the ground, your legs will or your feet will start bleeding immediately. Or if you are wearing thin slippers, now this stubble is so pointy that it can basically puncture your slippers as well, puncture your skin as well. So it is, first of all, if you extract it, then you can use it for production of ethanol, biofuel, etc. There are multiple and multifarious utilities that you can extract out of it. It is that problem of extraction which is the key. Are we able to extract it or not? That is why people burn it. Because if you extract it, fair enough, then you will never be needing to burn it. You can use it for cattle feed, you can use it as torrefaction, pelletization, all the other solutions come into the place. It is about that extraction. So why is it that it is not observed in the southern part of the country? That is because in the climate of the region regulated with land and sea breeze, also the region exposed to northeast monsoon. Partially correct, significantly correct. Benita, it's because temperature is suitable for wheat cultivation only in the, very good. That is as exact as you could be. Beneath Sridevi, because in southern India they will not grow more food grains like wheat. So it is what has already been encapsulated earlier. That is because in the southern part of the country, we do not experience such sudden climate change from October to, or change of weather from October to November, December. So in southern part of the country, you don't go through a large scale cultivation of wheat crop. Wheat is a rabi crop which is barely grown in southern part of the country. In very small areas, you grow them. In southern part of the country, rather the conditions are such that you can end up growing rice continuously throughout the year as well. For example, in many parts across the coastline, you have continuous growing of rice itself. You have different varieties of rice which are grown. So there you are not running against time, you are not having a battle against the time, right? So here it is only because of sudden change in weather condition which occurs in the northern part, where you have to sow the rabi crop before it becomes very very cold. So that is where you do need to do this, or that is why it is done in the northern part but not in the southern part. Rice also have stubble. It is primarily paddy. Paddy is what? Paddy is basically the crop from which rice is extracted. So primarily you will find that it is extracted from the rice crop itself, paddy crop itself. That is the stubble. Now, there are various different ways or the various different solutions which are offered, and various different solutions. We will talk about the pusa decomposer tablets as well, torrefaction, pelletization, etc. But when we talk about regions of South Asia and Southeast Asia, now these are also rice producing regions which produce rice in sufficient quantity, in very large quantities. So here, when we talk about these areas in particular, the areas, for example, Southeast Asia, Thailand, Laos, Cambodia, many of the farmlands or the farmers, they carry out a process of duck rearing for the process or for the purpose. So that is, they rear large number of ducks. Now, after they harvest the rice, now these ducks, they are left in large numbers, that is hundreds of them. They are left to roam about in these paddy fields. Why? Now these ducks, they basically will feed upon any kind of small pest or insect or worms which can in a way alter or damage these crops. So large amount of these ducks, etc., they basically chomp on and feed upon these worms which have been left behind. And while they do so, the ducks, they have a webbed feet. While they do so, inadvertently they will soften that stubble, and after they soften that stubble, then that stubble can be utilized, that can be tilled, that can basically be used when you upturn the soil, and then it will be returned as biomass into the soil. It is about softening of that stubble. Once the stubble is softened, then more than half of the purpose or half of the job is done. So this can also be cited as a kind of a solution. Many of the times you have this question about stubble burning being framed in the interview process. Even this year, for the Forest Service interview, we do know about a couple of candidates who faced this question about stubble burning. Now, when you are able to provide such constructive solutions, where let's understand that if you are talking about simultaneously taking care of the animal husbandry as well, you will be augmenting the farm income, you will be increasing the farm income in the process. So that is where simultaneously in an environmentally friendly manner, you will be taking care of that waste, that stubble waste. Along with that, you will be taking increasing the farm income by animal husbandry as well. Okay, we can have duck feet footwear and walk in those fields. Yes, you do one thing, you provide this solution the next time when you go to the interview panel and the interview board asks you this question. Provide them with this ingenious solution that we will have the specially made footwear and then we will do it. Please understand, it is not only the webbed feet which they do, but in order to chomp on to those particular worms, many of the times they will bite onto those particular thorny stubbles as well. So that also in a way softens and weakens it. So you can have a solution to it, that we will have a duck like beak as well to do the same. So those kinds of solutions if you can provide, well, after that, please don't forget to get in touch and tell me about the reaction of the interview panel. So that is something even I will be very intrigued and interested to know. But having said that, please don't provide that solution in all seriousness. Don't provide that kind of a solution. Okay. So this is the problem of stubble burning. And now we have another aspect or another particular cause of increased amount of pollution in the northern part of the country, and that is the topography and the location. So northern part of the country, geologically and geographically, is basically a continental area. It is not a coastal area. In the coastal area, you will have frequent mixing of the air with the help of the land and the sea breeze, right? But in the northern part of the country, you don't come across any of these factors. So here, first of all, continental region. So being a continental region means there is a significant lack of regular mixing of air as observed in coastal landscapes. Okay, in the case of the coastal landscape, you have this frequent mixing of air, which does happen. So it is not as if the number of vehicles in Mumbai is less or the number of vehicles in Kolkata is less. It is not as high, let's suppose, in as compared to Delhi, but it is still very significant. So that is why in the region of Mumbai, Kolkata, Chennai, etc., despite all those factors of pollution, still the level of pollutant in the air or atmosphere observed at any point of time is lower. Why? Because of that frequent mixing of air which is happening. That is not the case uh, in the northern part of the country. And secondly, in the northern part of the country, you have a distinct winter season. Distinct winter season. Now, when we have a distinct winter season, so in those conditions and cases, we come across a situation where as the temperature reduces and drops suddenly and quite significantly, what do we have? We will observe that as it drops, as it dips quite significantly, then you have the condition of surface inversion. I hope we are aware of that, that you have the condition of surface inversion. So distinct winter season you have due to colder conditions on the ground, surface inversion is observed. Is observed. And once this surface inversion is observed, means you have stable air, still air. That means there is a lack of mixing of air. That means the pollutant will stay in the same place for a longer period of time. That means the problem of pollution will be further exaggerated. How? So understand this entire cycle. And it is a kind of a vicious cycle. So once you have these pollutants which are emitted, now if the conditions are that is when we are talking about the winter months, now once these pollutants are suspended in the air, now they will be blocking sunlight to some extent. Now when they are blocking sunlight to certain extent, what will happen to the temperature on the ground? The ground becomes much colder. When the ground becomes much colder, simultaneously more pollutants are released. That means further sunlight will be blocked because all the pollutants will stay closer to the ground. Means further surface inversion will be exaggerated, right? So this process continues to happen, right? So here pollutants pollutants stay closer to the ground for a longer period of time block sunlight, and when that sunlight is blocked, that means what? Further cooling of the ground, of the surface. When you have a further cooling of the surface, that brings about more significant condition of inversion. And when we have more significant condition of inversion, that means more accumulation of pollutants. So that is where the situation, it starts worsening quite significantly. And you have to understand that the northern part of the country, it is landlocked, where the flow of the wind pattern, the regular movement of the wind is something that you don't experience, because it is from one side, it is blockaded by the mountains, the Himalayan mountains as well. So even if the winds, they try to move up, they are basically then again sent down, right? So the same air continues to prevail over the same region for a longer duration of time. Then we have the municipal solid waste. Obviously, when the population density is higher, the amount of waste which is generated will also be substantially higher, will be very, very high, the amount of waste which is generated. So all that municipal solid waste which is generated, all that waste, now, that waste is something which is kept in open dump yards of sorts. If you would have observed that you have large open dumps, for example, whenever you get an opportunity to visit Delhi, anywhere around Delhi that if ever you get a chance to, let's say, get onto a high tower or a high building in Delhi, you will always observe that there is a kind of first of all, a lot of haze and a kind of a mound like hill like structure all the way around Delhi. And if you look at the topography or and the relief features of Delhi, you'll be surprised to know that Delhi doesn't have any hill range, not anymore. It used to have hundreds of years ago, millions of years ago, but not anymore. So what are these mounds? These are the garbage dumps. Few of these garbage dumps, they are even larger, they have gained a height even larger than Qutub Minar. So that is our own contribution, what we have done. We have managed to create such man-made or such wonders, which, let's say, we are celebrating the height of Qutub Minar, and we keep on celebrating that, okay, what kind of construction was done in the 12th century where you constructed such a tall minaret. But we managed to do that by wasting or by simply dumping the waste. So that is where we need to celebrate that kind of waste dumping in a way. So that waste dumping which we have done in very large proportions. Now whenever you have waste open dumps, not only do they become sources of significant amount of diseases, they, whenever you go around that area, there will always be that continuous foul stench that you will be exposed to. But also, this will continue to emit gases. If you consider open waste or waste dumps, this will continue to emit various different gases, gases such as methane, hydrogen sulfide, furans, etc. Now, these are highly flammable gases. That is, they can undergo combustion very easily. That is, methane is highly combustible. And because you have presence of so many different types of organic waste, biomass, very light grade of plastics, so many of the times it happens, especially during the dry season, that when there is excessive amount of heat, in the presence of these gases, they catch fire immediately. And once they catch fire, that is when everything will start burning, everything will start burning, and it will emit lot of waste gases in chief. Okay, so due to in drier conditions, these waste gases catch fire easily in the presence of dry waste such as biomass, and also you have the presence of plastics, etc. Now when they catch fire, that is when they will be releasing lot of various different toxic gases. So that is when they release large quantities of toxic gases. And if ever you have had the misfortune of witnessing any of these fires, it is as apocalyptic as you can imagine. The entire sky turns blackish almost, the visibility reduces. As you move onto the road, you will have the ashes which keep on dropping on the middle of the road. And that is where the amount of pollutants, the toxicants that are inhaled by the people, that is simply incomparable. So, what is the solution to it? The solution is something which many of the countries and especially regions such as Singapore, they have been following for a long period of time. If you take a look at Singapore, it is one of those ideal cases and ideal examples of how to manage the waste. Because Singapore is a very small city of sorts, right? It doesn't have a large land area like we do in India. So, despite the high population density and the large amount of waste which is generated, they take care of that waste. So, what is done? They segregate that waste into wet waste, dry waste. Dry waste is then recycled, wet waste is recycled into various different types of organic manures, and dry waste is then, depending upon the type of materials that you have, it can either be um, burned to produce electricity, to produce energy, and that is the proper handling of the waste. That is the reason why immediately after election, in many of the state governments, you will observe that the Ministry of Urban Affairs, in many of these state governments, immediately after getting elected, they take a long trip to Singapore. Not a short trip, long trip, month long trip to Singapore in order to study the waste handling. And this is a kind of a norm which many of the state governments are doing. And I'll not take the name of the particular state governments because then it becomes political. Everybody does that. Now, and why do they do that? To understand and inculcate the same practices here in India. But obviously, that is not being done, that is not being implemented. So, what is it that our problem is in this case? So, here we can actually go for the waste to energy production. Waste to energy production is one of the ideal methods and is one of the clear cut methodologies to handle this open waste. Now in Delhi, amidst lot of fanfare and lot of significant amount of announcements and lot of public enthusiasm, you had the launching of the Okla waste to energy plant in New Delhi, which was done. And it was being cited as the final solution to the problem of the Delhi's pollution. But you will be very surprised and at the same time intrigued by the decision makers and the bureaucrats of our country that the court had to basically order the shutdown of this plant. Ideally, this plant was to utilize this open waste and then produce energy by burning of that waste. But it was found out upon investigation that this plant is causing more amount of pollution as compared to the open dump sites, because by burning of these waste we are not filtering out the gases and we are releasing them directly. So the amount of pollution caused by these energy waste to energy plants were so very high because the equipment was so substandard. That is where this added to the problem. But if it is carried out in a careful manner, then it can provide a long-term solution. So that brings us to the portion of the probable solutions to the problem of pollution. So here, when we talk about the stubble burning, so for stubble burning, you have the decomposer capsules. Now, what are these decomposer capsules? So these are the capsules which have been released by PUSA. So that is why it is referred to as the PUSA decomposer capsules as well. Now, this PUSA decomposer capsule, it ensures it is mixed with us and mixed with water, and there is a solution which is created, and then it is sprayed over the stubble farm. Now, after that, what is done is that it is left over for some time. Now, this solution, it increases the microbiological activity and reactions, and that automatically softens the stubble. So it is sprayed as a solution, and it softens the stubble by carrying out increased microbiological activity. Okay. Now, as a result of that, you have a situation where once the stubble is softens, the land can be tilled and the stubble can be decomposed. It will also improve the organic content or the humus content of the soil, will increase the fertility of the soil in the medium to the long run as well. So this is one of them. Then other is pelletization and torrefaction. Now, in that case, what is done is that these basic stubble, once you are able to extract that, the problem lies in extraction of them. But if you are able to extract them, after that, that is converted into small biomass based tablets or pellets, and those pellets, they serve as the source of energy, in the sense that they can be used for combustion process, because that also consists of carbon, and when you carry out the combustion of carbon, energy is produced. So that is where, by converting the stubble into pellets, there can be a greater utilization in terms of production of energy for various different industries which require the availability of energy. And this is something which has been mandated for the power plants in the region, where the government is also envisaging to make it mandatory across all the various power plants to utilize certain section of or pellets which are manufactured and made by this particular stubble. Now, once you are able to do that, you will not only be able to take care of the problem of the pollution, but simultaneously you will also be able to take care of the fact that the farmers, they are able to earn enough. Okay, because by selling that stubble, they will be given some amount of money. Now, also, there is another aspect where this stubble can also be is being utilized to form packaging materials, right? So again, the problem comes with the process of extraction. If you are able to extract them, so you have these large scale extractors which have come into the market as well, but they are very costly. So a small individual farmer, it is beyond his or her scope to buy those extractors. So that is where it is required to form large farm cooperatives, and then these group of farmers together, maybe they can buy that and they can use it on their field. Now, here, that is how you can take care of that stubble problem. Then you have the anti-smog towers and anti-smog guns. Now, what are these anti-smog towers and anti-smog guns? So, anti-smog tower, this is the image of that. So, that is your anti-smog tower. While the technology has been in existence for a long period of time, its prevalence in the large scale and utility in the large scale is something which increased substantially and exponentially during the Beijing Olympics. So when you had the Beijing Olympics which was held, that was basically a time for China to showcase its developmental prowess for the rest of the world. The world knew, and everyone knew, that China had been developing at an incredibly fast pace since the late 70s, 80s, 90s. So when China was hosting the Olympics, it was a matter of prestige for China. But at that point of time, the condition of Beijing in terms of the air quality was very similar to what you observe in Delhi right now. So what Beijing did, and China does, if anything that China does it at a scale. So China immediately, it started putting in large scale anti-smog towers. Now what it does, it basically filters out the air. It is like an air purifier of sorts in simple method. So here the polluted air is taken in through the inlet valves, and then that polluted air is passed through various different scrubbers where the pollutants, they are separated, and then after that, that filtered air is basically blown out with the help of the various different fans that you have. So as you can see, you have close to around 5,000 filters in that tower in order to filter out the pollutants. So that is how eventually you have the cleaner air which is to be provided. So this is a factor, or this is a kind of a facility which can be done. But obviously, again, observe the kind of the media fanfare, the kind of a popularity, and the kind of prominence which is given every time one anti-smog tower is inaugurated or established. I hope we are aware of the fact that this anti-smog tower will have a limited reach. For a large area such as the region of the national capital region of Delhi, you will end up requiring endless amount of these anti-smog towers to be functioning. Okay, so one or two such towers will hardly solve the purpose ever. So the solution is the taking care or getting rid of the pollutants altogether. And then you also have anti-smog guns. What are these anti-smog guns? So these are basically installed on the lorries of the large trucks. Okay, you will observe them to be installed on the lorries of the large trucks, where you will observe that the construction mechanism is very simple, like a cannon shape. It will have a kind of a cannon shape. Okay, and there it sprays very tiny droplets of water into the air. Very, very tiny droplets of water, they are sprayed into the air. Okay, these are your tiny droplets of water. In majority of the cities nowadays, early in the morning, you will observe this, of water is sprayed. Now, what is the purpose of this? This is basically obviously attached to a larger truck or a larger trailer of sorts, and then that is how it moves. So the purpose is to take care of any kind of particulate matter. That particulate matter will get saturated with water, it will get heavier, it will get deposited to the ground. So these anti-smog guns, they basically are there to take care of the dust particles and the particulate matter, to get rid of dust particles and particulate matter. Okay, that is something that you observe here. Now, other than that, what can be done? So, vehicular emission is one of the major factors creating that pollution, creating the amount of emission. Transportation sector in general in itself creates a lot of pollution. Around 27% of the pollution is attributed to the transportation sector alone, outdoor air pollution. So that is where we can go for a modern technological feat or modern technological vehicles where we can have hydrogen based fuel technology. Now, in the case of the hydrogen fuel, you carry out the combustion of hydrogen. And when you carry out combustion of hydrogen, what is produced as the end product? It is basically hydrogen combines with water. So, when you carry out combustion of hydrogen, in the case of hydrogen vehicles, that is where you have H2 plus O2 produces H2O. So that is where water vapor or water is produced as an outcome. This is the output. So it is much more environmentally friendly. In fact, it is completely environmentally friendly. The problem is that this is a costly endeavor. Then we can have the vehicle policy. Now, under the vehicle policy, we can have multiple subdivisions here. First is, when we talk about the vehicular policy, the first is the aspect of electric vehicles. Okay, the various different electric vehicles which are there. Now we can provide tax breaks and tax incentives, and in a way encourage people to use more amount of these electric vehicle technology. Secondly, that needs to be promoted. Then secondly, we also need to establish emission standards and emission norms. So modern emission norms such as BS6, right, which are not only at par with the international norms, but we can take a step further, because it is not our role to be playing footsie or be at par with the globe. We can always, in a way, envisage or envision ourselves to take a step further. So, modern emission norms such as BS6, and third, with the implementation of the vehicle scrappage policy. Implementation of vehicle scrappage policy. Now, that vehicle scrappage policy overall, when we talk about the vehicle scrappage policy, what is that? I hope we are aware of the vehicle scrappage policy established by the government. So, that is where older vehicles, their registration has been made much more costly, much more stringent re-registration of them, and in a way it has been disincentivized to use older vehicles anymore. So that is where it will encourage the circular economy, where in the sense, not only are you incentivizing people to get rid of their older vehicles, because older vehicles means older technology, means greater amount of emission, means greater pollution. So not only are you incentivizing people to go for a cleaner vehicle and a cleaner technology, but also here you have to understand that once you are scrapping those vehicles, so there will be a kind of a recycling industry which is very nascent in India as of now. But that industry is very large in Europe. That industry is very, very large in United States. So, or in North America in general, and even in China. So when you are recycling the older vehicles and selling them into the scrap yards, so what they will do is they will recycle the materials: steel, aluminium, fibers, fabrics, glass, everything. And once you are able to do so, then what will happen? The price of the commodities such as steel, aluminium will come down. And once the price of these materials come down, then what happens? In that event, you will come across a situation where the newer vehicles will also be slightly cheaper. And in the process, you will end up creating a lot of new jobs, a lot of greater demand in the economic setup. So this will end up establishing a virtuous economic cycle, which will be beneficial. Odd even number vehicle. Well, odd even number vehicle is not something um, which is not very, in a way, productive. It will only reduce the vehicle density. Okay, it is not something which is significantly very productive in the long run. In the long run, it will be much more productive. For example, take a look at Beijing, Singapore. Now, in these areas, the getting a newer vehicle is something which has been made very costly, in the sense that the registration plates, if you want to buy a new vehicle, first of all, you need to get the registration plates. And there is a lottery for the newer registration plates. So you cannot have more than XYZ number of newer vehicles in the road any particular year. So when you limit that number of vehicles which will be moving on the road, that will be much more sustainable. Okay, otherwise, what is happening in presently under the garb of that odd even policy is people are buying 2 or 3 vehicles. They have one with an odd number, they have one with an even number. So that is not solving the purpose overall. Okay. By the way, this odd even policy is something which is implemented in various other cities of the world, such as Manila in Philippines, which has got one of the worst traffic problems. Obviously, not as bad as Bangalore, but then it has also got a very severe amount of traffic problems, and it is defamed across the world. But there, that odd even policy is much more complicated, and that causes, in the lack of public infrastructure and public transportation network, that causes humongous amount of issues as well. Okay, Pranay, class was started at 12. Then we have the graded response action plan. What is the graded response action plan? So this is basically a kind of a standard operating procedure which is established, that if the amount of pollution, let's suppose, is at X level, then these can be the steps or the measures which can be taken. If the amount of pollution is at Y level, these can be steps or the measures which can be taken. If the amount of pollution is more than that, then order the shutdown of the schools, order the shutdown of the construction activities, order the presence or the removal of these kinds of vehicles. That is your graded response action plan. So that can also be initiated. Okay. So these were few of the solutions. Now we come to the portion of ozone layer, and then we will take a look at the government actions and few of the government's initiatives as well. But before that, you have the 20-minute break, which is in front of you. So we have delayed that break by almost 20 minutes in a way. So fair enough. Let's take a break. Your snacks break on Saturday overall. So take a 20 minutes break and be back, and then we will continue. Okay.